February 1943. On the dry sands of Sidi Bou Zid, Tunisia, a group of German officers surrounded a downed enemy tank, or at least, that's what they expected to find. But the captured M4A1 Sherman was undamaged. There was no smoke, there was no failure. It was intact, working, and silently defying the logic of those who observed him. The American symbol still visible under the hastily painted cross made it clear this was not a German project. It was something worse. It was something that worked. For the Germans, armor was an art. Transmissions required surgical precision. Machines in their heyday could only be operated by men trained as surgeons. So what followed was more than a technical experiment. It was a clash of civilizations. The tank they had underestimated would reveal in embarrassing detail that German doctrine was not advanced. It was fragile, and that Americans were not naive. They were unbeatable, because they thought differently. This documentary exposes what German engineers discovered at the Kummersdorf test grounds, that reliability, standardization, and robustness win out over genius alone. A technical, historical, and ironic analysis of the time an American tank dismantled German arrogance forever. But before we dive into the data, there's one statistic that defines this story better than any metaphor. In tests carried out by German engineering itself, a single M4A1 Sherman traveled more than 2,000 kilometers without needing major repairs. In contrast, the first models of Panther, an icon of Nazi war engineering, failed with less than 500 kilometers of continuous use. An American tank, designed to be simple and inexpensive, endured 4 times as much as Germany's most ambitious promise. At Kummersdorf, engineers who had sworn allegiance to the technical superiority of the Reich were required to record with German accuracy that they had lost to American robustness. That's it. It was just the beginning. If you value history with data, engineering with context, and analytics that go beyond the surface, support this work. Leave your like, subscribe to the channel, and help keep alive the stories that the war almost buried. When the Sherman tank arrived at the port of Sfax in Tunisia, German officers still did not know what they had captured. It was just another enemy armored vehicle abandoned during the chaos of the American retreat. But something drew attention. The vehicle was intact, worked, and he had traveled in the hands of a Wehrmacht reconnaissance unit almost 350 kilometers without any mechanical incident. The white American star still visible under the hastily painted cross made it clear that it was an M4A1, a standard model, with a Continental R975 radial engine and a construction that, to German eyes, seemed rudimentary. But that tank did not fail. And this simple detail was enough that for the first time, the Nazi war machine decided to send an entire enemy tank to Germany for tests, not as a trophy, but as a puzzle. Embarked on a cargo ship and classified under the code Zugkraft 259, the vehicle was transported north in secret, with explicit orders not to be dismantled, damaged, or modified. Their destination, the Kummersdorf Proving Ground, 25 kilometers south of Berlin. There, in facilities surrounded by secrecy and rigor, the technical brain of the Wehrmacht operated. It was in Kummersdorf that captured armaments were subjected to the most meticulous military testing program in Europe. Soviet planes, British rifles, French artillery, they had all passed through there. But this American tank caused a different reaction. The engineers of the Armored Evaluation Section did not expect any surprises. They knew the rumors about the American production. They knew that the U.S. manufactured at scale, not with art. To them, the Sherman was just a tractor, disguised as a tank, ugly, tall, poorly designed. German technical doctrine saw tanks as instruments of precision, war machines whose performance depended on the beauty of the calculation, the excellence of the gear, the purity of the construction. What they found dismantled that vision in a few days. The M4A1 arrived with its original paint job still visible under the desert sand. Its name, War Daddy 2, could still be read on the hull. The engineers started with the obvious: photographic documentation, armor thickness measurements, turret and hull pitch calculations. The first discomfort arose with the transmission. The helical gear system, an industrial standard in the U.S. since the 1930s, was something Germany thought impractical for tanks. They required special machines, technical training, and a standardized production chain. But here it was, serially installed, running smoothly, and with minimal wear levels, even after hundreds of miles under wartime conditions. The astonishment intensified with the cooling system. Simple, straightforward, but capable of keeping the engine within the ideal temperature range even under African heat. The air filters operated without clogging. The lubrication remained uniform. The engine, even under inspection after days of land crossing, showed no signs of overheating or excessive friction. And then came the first numerical shock. According to German estimates, the United States was capable of producing more than 2,000 tanks per month in 1943, a number that surpassed all German production accumulated between 1940 and 1941. It was the first time that those engineers weren't just seeing numbers on paper, they were looking at the final product of that scale. If this data impresses you, write here in the comments. Shocking data, because the Germans simply ignored it until it was too late. What was once treated with condescension has become feared. The Sherman did not impress with armament statistics or armor thickness, but it worked. Always. And that, for an army that fought on multiple fronts and faced constant failures in its Panthers and Tigers, was the rarest quality. During the first tensile tests, Kummersdorf's engineers recorded with amazement the Sherman's performance on varied terrain. Mud, gravel, slopes. None of them had significant failure. The suspension remained stable. The gearbox responded well to all load demands, and fuel consumption, although high, was compensated by the ease of refueling and maintenance. The design, even under critical analysis, revealed generous tolerance margins, allowing operating errors without catastrophic damage. Technicians began to write down observations that were previously unthinkable in official documents. Phrases such as extraordinary simplicity of maintenance, robust system even under operational abuse, and design visibly geared towards mass production and reliability appeared in the internal reports. For the first time, German engineering saw with their own eyes that a tank could be functional, reliable, and durable without relying on the near craftsmanship precision they prized. But the most symbolic moment was yet to come. In an inspection report written after the turret was dismantled and the rotation system examined, a chief engineer from the evaluation department wrote, "This tank is the first enemy equipment that forces us to recognize a design philosophy entirely different from our own, and possibly better suited to the requirements of modern warfare." It was a veiled but unequivocal admission. Sherman didn't just work. He forced Germany to look in the mirror. And that was just one copy. Other Shermans, captured from British forces in Italy and Soviet forces on the Eastern Front, began to arrive at the proving ground in the following weeks. Each of them had slight variations, but shared the same core: durability, consistency, ease of operation. Engineers have documented this obsessively. They were beginning to understand that the United States had not only produced more tanks, it had created a functional armor ecosystem, based on civilian experience, automotive knowledge, and adaptable production. But the real turning point was yet to come. Because after recording every measurement, every test, every comparison, the Kummersdorf engineers would make a difficult decision: to put the American Sherman to a public test, side by side with Germany's most modern tanks, in front of Reich ministers and Wehrmacht generals. A direct technical confrontation, a stage where German confidence would be put to the test, and, as we will see in the next part, the result was everything less worthy of applause. The first test session with the M4A1 Sherman began like any other technical protocol at the Kummersdorf field. No rush, no fanfare. An enemy tank, captured, examined with the same skepticism that reserves something inferior, disposable. The expectation was clear: to disassemble the vehicle, map out its mediocre engineering, and use it as an example of what Germany should never emulate. But as engineers activated their measuring instruments, something unforeseen began to emerge. The Continental R975 radial engine, although packed into a space that the Germans considered to be poorly distributed, responded with constant power, even after long periods of static operation. No significant temperature rise, no loss of torque, no sign of anticipated wear. Under controlled laboratory conditions, it operated with the same efficiency as the first spin in the Tunisian desert. The cooling system, simple, straightforward, with no redundancies, maintained thermal stability with an efficiency that humbled the complex cooling systems used in the Panthers and Tigers Maybach HL210 and HL230 engines, known for chronic overheating under prolonged stress. When they dismantled the gearbox, they expected straight-cut gears, as in German vehicles, components that required very high-precision machining and constant maintenance to avoid failure. What they found was another philosophy: helical gears in herringbone, capable of distributing load across multiple teeth at the same time, reducing wear and increasing durability. This technology had been common in the American civilian automobile industry since the 1930s, but was considered unfeasible in military production in Germany, as it relied on tools and manufacturing practices that simply did not exist on an industrial scale in the Reich. Yet here they were, operating without excessive noise, with minimal need for additional lubrication, and tolerant of human error. The doubt took shape for the first time in silence. No glitch, no anomalies, no obvious design defects. Each system examined reinforced the nagging suspicion: the Sherman had been designed not for engineers but for ordinary soldiers. It was too simple to fail, and this observation was more offensive than any Soviet supercannon or British artifice. Because the M4A1 didn't win in direct combat, it won by simply continuing to function when the others stopped. The VVSS, vertical volet spring suspension, often criticized for providing a rough ride, proved to be stable, resilient, and easy to repair with basic tools. The air filtration system resisted the entry of fine sand without clogging, something German tanks were never able to control in the deserts of North Africa, where even the Tiger was often abandoned due to failures in the intake system. The turret rotated smoothly by hand and could be operated even without the main engine running, thanks to an electric auxiliary generator, a detail that seemed superfluous luxury until it proved vital in real combat conditions. The armor, although less thick than that of German heavy tanks, was well angled and built in cast sections that accelerated production and ensured structural consistency. Every detail pointed to a central reasoning: designing for scale, for durability, and for quick maintenance on the field, not for technical medals. Kummersdorf's engineers began to revise his notes. With each system tested, a new discomfort arose. What was supposed to be inferior was systematically exceeding fundamental technical expectations: transmission response time, cornering stability, engine response under load, vibration resistance, track alignment maintenance. The tank didn't just work, it worked on a margin. Nothing there was on the edge, and that was the most humiliating. The Sherman was designed with ample operational clearance, allowing soldiers with basic training to keep it in combat for weeks, even under hostile conditions. The Panther, in contrast, required specialized technicians and fine-tuning in almost every overhaul. The Tiger, even more powerful, was a masterpiece that shattered by stumbling over its own perfection. These contrasts ignited the internal debate. A series of memos circulated among the Wehrmacht's technical departments, warning that American tanks were not, as it was said, adequate, but rather excellent at what the war really required. And this was not a figure of speech. It was a strategic threat, because Germany could not, even if it wanted to, reproduce what the Americans had done, a machine that operated within the margins of the world's most advanced industrial civilization. The Sherman didn't just represent a tank. It represented an entire ecosystem of mass production, pragmatic engineering, and civilian know-how applied to combat. The doubt became official. An engineer noted in his technical diary the following sentence: "If this is the enemy's pattern, then our problem is not just tactical, it is structural." The phrase was censored in the final reports. But internally the feeling was clear. The war was already tilted in favor of those who knew how to make not the best tank, but the most reliable, and by the thousands. Because German doctrine depended on vehicles operating in optimal conditions, with highly trained crews, specific spare parts, and expert technical support, the Americans, in contrast, made tanks that any tractor mechanic could repair. This quietly nullified all of Germany's intellectual investment in extreme sophistication, and it was just the beginning. The next step would no longer be a secret. For the first time, the High Command would authorize the Sherman to be publicly compared with the Panther and the Ferdinand, the two symbols of German superiority in armor. The date has been set. The place would be Hillersleben. The presence: generals, engineers, ministers, and Reich officers. It would be a show of strength, but what they would witness there would turn this meeting into a spectacle of national embarrassment. The Panther was conceived as a response to the Soviet T-34, but its true antagonist would prove to be much quieter and more constant: the American Sherman. In theory, the Panzerkampfwagen Full Panther was the pinnacle of German combat engineering: frontal armor up to 80 millimeters, 75mm gun with high muzzle velocity, 700 horsepower Maybach engine. On paper, it was a masterpiece. In practice, a structure that collapsed under the weight of its own ambition. The first vulnerability emerged at the heart of mobility: transmission. The Panther used an AK 7-200 gearbox, originally designed for lighter vehicles. In the field, under the weight of 45 tons, this transmission became a constant breaking point. Third gear, in particular, had such a high failure rate that German field manuals recommended avoiding it altogether. Excessive shifting was discouraged. Driving needed to be strategically smooth. This limitation, in a war environment, was disastrous. In contrast, the Sherman used a 5-speed manual transmission with partial synchronization, allowing direct shifts from second to fifth without the need for dual clutch. For soldiers who had driven civilian trucks or tractors, operating the Sherman was almost intuitive. This facility reduced training time and the risk of failures due to human error, a luxury the Panther could not afford. The fragility did not stop there. The final units of the Panther, the set of gears that transmitted power to the tracks, were inherited from the Tiger design, but subjected to a new level of stress. With straight-cut gears housed in narrow housings, these systems suffered under any abrupt variation in torque or asymmetrical friction on the tracks. The result was predictable: catastrophic failures. Field reports from the Eastern Front indicated that fresh Panthers, fresh from the factories, needed to be towed after less than 100 kilometers of operation. In mountainous or muddy regions, the problem worsened. A foreign object stuck in the conveyor belt could jam the entire system. Maintenance away from the technical rearguard was impractical. Many vehicles were simply abandoned due to mechanical failure before firing a single shot. The Sherman, on the other hand, used final units built with helical gears and standardized materials that allowed for quick replacements. Its design avoided overloading components. In tests at Kummersdorf, engineers noticed that the Sherman's powertrain demonstrated not only durability, but functional redundancy. Parts operated with a margin of tolerance, preventing chain failures. The accessibility of the components was another chasm between the two vehicles. The Panther required partial dismantling of the turret for engine access. To replace a damaged transmission, the vehicle had to be sent back to the factory or dismantled by specialized technicians. In combat, this meant that an immobilized Panther was, in practice, a definite loss. The Sherman, on the other hand, allowed the engine, transmission, and final units to be changed with conventional tools, in the field, in less than 10 hours. It was a tank designed to be maintained by human hands, not laboratory engineers. This difference exposed a central dilemma in the German industrial mindset: designing for absolute excellence, even if it made the machine unsustainable in a real environment. American engineering designed for endurance, even if it sacrificed technical elegance. The Panther, with its 45 tons, required fuel at levels that German logistics could not keep up with. Its Maybach HL230 P30 engine was powerful but voracious. Practical autonomy was limited not by the capacity of the fuel tanks, but by the reliability of the components. The Sherman, on the other hand, even with high consumption, operated with regular gasoline, had robust fuel filtration systems, and maintained its real autonomy at satisfactory levels, on average 160 kilometers with a full charge. In strategic terms, this meant that a battalion of Shermans could move, fight, and return with minimal support. A battalion of Panthers needed complex logistical planning, advanced technical support, and time, something that the war, especially after 1943, no longer offered Germany. Kummersdorf's engineers noted with growing discomfort that the Panthers' failures were not isolated cases. They were standards. An internal memorandum from September 1943 recorded that the operational reliability of the Panther model remains below 40% in field environments. This dry and technical phrase concealed an embarrassing truth. The pride of the German armored industry could barely get out of the rear. By contrast, the Shermans operated with average readiness rates above 80% on all fronts. They didn't have to be the best at everything. They just had to be ready to fight. The most tragic thing, in the eyes of the engineers themselves, was that the Panther's problems could not be solved with simple adjustments. They were structural. They would require years of redesign, non-existent resources, and protected factories, a luxury that Germany, under constant Allied bombardment, had already lost. In Kummersdorf, the tests with the Sherman continued. And with each new report, a certainty emerged. Germany had built tanks to impress, the United States had built tanks to last, and that more than cannons was what won battles. The next test would be even more humiliating. In front of ministers and generals, the Sherman would be pitted side by side with Germany's best tanks, in a public display that would leave no room for technical excuses or doctrinal theory. Because on that day, even the mighty Ferdinand would fail in the face of the brutal simplicity of the American tank. The design logic that created the Sherman wasn't born on a military base. It was born in Detroit, and that made all the difference. While Germany built tanks like Swiss watches, set to the limit, dependent on specialized engineers and zero fault tolerance, the United States applied the principles of civilian industry to the battlefield: repetition, standardization, and robustness. The Sherman wasn't a jewel. It was an armored tractor with an efficient gun. It used interchangeable parts between different factories, engines adapted from aviation and agriculture, and systems that could be disassembled by a recruit with a wrench. The genius was precisely in the absence of preciousness. While the German troops waited for rear technicians to change Panther transmissions, the American units carried spare engines in the logistics truck. It only took hours to return to combat. This philosophy was not a coincidence. It was intentional. The U.S. Army knew that the war would not be won by experts alone. It would be won by ordinary soldiers. Every Sherman bolt reflected this reasoning: error tolerance, ease of repair, speed of production. The Germans, on the contrary, favored complexity and extreme performance. They designed machines that relied on elite operators and maintained production lines that rejected non-standard parts. The result was predictable: tanks that glow in manuals, but collapse into the mud. The irony of this story is that the solution was in front of them, but their industrial culture did not allow them to see. If you are enjoying unraveling these facts and analyses ignored by history books, show your support. Like and subscribe so that we can continue to bring you content with this depth, because this clash of mentalities is not over yet. In the next part, we will see what happened when the German engineers decided to put the Sherman to the test, side by side, with their tanks of national pride, and the result was a silence that not even Reich propaganda could disguise. For weeks, Kummersdorf's engineers conducted meticulous tests with the Sherman M4A1. Everything was recorded: fuel consumption, performance on different types of soil, thermal response under load, wear and tear of components after combat simulations. The methodology followed the rigid standards of German technical doctrine, and precisely for this reason, the results could not be contested. The first number came as an uncomfortable whisper in the corridors of the complex: 2,089 kilometers. This was the distance traveled by the Sherman, in continuous cycles, without critical mechanical failures, without the need to replace larger parts, and without specialized technical intervention. Basic maintenance only: lubrication, filter cleaning, and retightening connections. The report stated with Germanic coldness that the drive system retains full functionality after an extension of more than 2,000 kilometers. In comparison, the Panther tested in parallel reached transmission structural collapse with 524 kilometers. The third gear, again, failed, even with idealized driving and absence of combat stress. The cooling system required 4 interventions, and the tower braked twice during rotation tests under tilt. The Panther's fuel consumption exceeded 2.5 liters per kilometer on average. The Sherman, with a radial engine powered by gasoline, maintained an average consumption of 1.7 liters per kilometer, and with simplified logistics supply. More than an operational victory, it was a technical humiliation. Every line of the German reports documented an inferiority that could no longer be denied or disguised. The engineers tried to justify the results with technical arguments: higher weight, more powerful gun, sloped frontal armor. But the spreadsheets ignored vanity. They only showed numbers, and the numbers showed an uncomfortable truth. The mass-produced American tank, designed to last, won not in the shot, but in time. The Wehrmacht relied on tanks that lasted for hours. The Allies produced tanks that lasted for months. This difference was not tactical. It was fatal. A final report, signed by 3 senior engineers, contained the following observation: the M4A1 has technical characteristics that do not correspond to the simplicity of its construction. There is a mismatch between its appearance and its functional performance. This forces us to reconsider mechanical evaluation criteria from the perspective of durability. Translation: the tank they considered primitive, it worked better, and what they called superior, broke. But not everyone was willing to accept this result. In the next part, we will see how the High Command reacted to these reports, and how, in front of a closed meeting, a German officer dared to say for the first time that the problem was not the enemy's tank, it was the country that had designed it. During the spring of 1943, the Hillersleben Proving Ground in northern Germany was the scene of an unusual and embarrassing event. Gathered under the guise of a technical demonstration, engineers, officers, and senior Nazi figures positioned themselves in front of a row of carefully lined tanks. Among them, the Panther, a symbol of German war pride. The Ferdinand, technical colossus designed by Ferdinand Porsche, and discreetly next to it a tank painted olive green, with stars partially covered in gray paint. The M4A1 Sherman captured in Tunisia, still identified as Zugkraft 259 in the internal records. Albert Speer, Reich Minister of Armaments and Munitions, watched with folded arms. He knew that this display was not just technical, it was politics. The Reich needed to prove to itself that it was still superior, that its engineering could still win by precision. But the field does not respect theory. The main test was straightforward, a 35-degree slope with uneven ground, simulating a rocky hill like those found in Italy and the Balkans. First, Panther. It roars, moves forward, but its stiff suspension and excessive weight make it lose grip mid-climb. Try again. Locks the right track. The engine overheats. Retreats. Second attempt. The gearbox jams. End of the test. Then, Ferdinand. At almost 65 tons, it advances like a steel monster, but the access curve requires maneuvering. The traction system fails when trying to adjust the angle. One of the treadmills jumps. The test is terminated for safety. And then, the Sherman. The American tank turns on with a deep, almost informal rumble. It moves forward fluidly. No setback. No hesitation. The suspension absorbs the irregularities of the terrain. The traction maintains constant contact with the ground. Climb the hill. And in less than 40 seconds it reaches the top, without failures, without excessive noise, without a single expert operator. An uncomfortable silence dominates the line of spectators. Albert Speer says nothing. Just write it down. One of the engineers comments, almost voiceless, "It worked." For a military doctrine that had staked everything on technical superiority, that moment was more than an embarrassment. It was a symbolic collapse. The enemy's tank, considered simple-minded, had just surpassed the greatest icons of German industry, before their own creators. But this scene, in itself, was not the most painful part, because shortly after the event, a dossier was sent to the Chancellery. Its contents didn't just describe the Sherman's performance, it questioned Germany's own ability to adapt its industry to a protracted war, and within that document was a phrase that Speer, in particular, never forgot. A phrase written by a colonel in the technical area, who said, "We did not lose to a tank. We lost to a culture that learned to manufacture with humility." In the next part, we'll unravel what happened to that report, and how it was buried under the rhetoric of an empire that could no longer accept the truth. In August 1943, a discreet article was published in the Nachrichtenblatt der Panzertruppen, the official bulletin of the German armored troop. Signed by an engineer captain from the Technical Department of Armaments, the text analyzed armored vehicles captured in North Africa. But, curiously, he dedicated 2 entire paragraphs to a single model, the M4A1 Sherman. The tone was respectful, almost reverent. The author described the vehicle as exemplary serial production with technical merit, and highlighted the impressively effective use of gyroscopic stabilizers in the main armament. For attentive readers, the praise was a veiled message. In bureaucratic military language it meant, "We cannot do the same." The text further acknowledged the modular standardization of the American tank, noting that the interchangeability of components demonstrates remarkable industrial maturity. For a Reich bulletin, this was an awkward admission, because among the diplomatic words there was a confession. The Americans had reached a level of production that Germany, with its decentralized and elitist technical structure, could never replicate in wartime. And if you found this surprising, it's worth remembering that in 1943 the United States produced about 2,000 Sherman tanks per month, while Germany barely reached 250 Panthers. That's right, a difference of almost 8-1. If this impresses you, write here in the comments. Logistics wins, because the war in the end is won in the factory. The article was reproduced in only 3 editions. Then, he disappeared. But among the engineers, it circulated like a technical whisper of warning. The enemy had understood war as a system, Germany as a prestigious duel. In the next part, we'll understand why American mass production wasn't just a logistical feat, but a cultural triumph that began long before the first conveyor belt. During the autumn of 1943, a new Sherman example was unloaded onto the Kummersdorf tracks. It was not a standard American model. Its 75mm gun had been replaced by a much longer gun with an aggressive muzzle brake and unmistakable shape, the British Ordnance QF 17-pounder. It was a Firefly, the Anglo-American variant designed by British engineers to go toe-to-toe with the Panthers and Tigers. What the German technicians did not expect was the ease with which this transformation had been made. The Sherman's turret, originally conceived with ample interior space and robust structural support, had accepted retrofitting without compromising the tank's balance or its internal operation. It was not necessary to redesign the suspension. It was not necessary to move ammunition compartments. It was not necessary to change the hull structure. In industrial parlance, this meant only one thing: scalability. The Firefly was living proof that the Sherman wasn't just a reliable tank. It was a war platform, a chassis designed to accept the future. Meanwhile, the Panther, with its narrow turret and critical weight distribution, could not receive larger guns without a complete redesign. Any attempt at modification entailed prototypes, destructive testing, and re-engineering. The Tiger? Even worse. Each piece was so personalized that it made it virtually impossible to adapt it to scale. German pride had created tanks as works of art, unchanging, imposing, but static. The Allies had created tanks as operating systems, upgradable, modular, open to adaptation. An engineer in Kummersdorf, after studying the Firefly for days, noted with restrained irritation, "It is technically inferior, but industrially, it's perfect." The phrase was not inserted in the official report, but it spread among the runners like a sentence of defeat, because if the enemy could adapt his tanks faster than Germany could design his own, then there was no more time. And perhaps the most symbolic fact of all, the British Firefly with a 17-pounder gun had greater penetration power at 1,000 meters than the Tiger I cannon, a British gun, and an assembly line ready to manufacture thousands. In the next installment, we'll look at the devastating effect of this capability on the battlefields of Normandy, where Allied tanks have started to appear more frequently and with more strength. The reports began to change tone. In Kummersdorf's early technical papers, the Sherman was described as suitable, strategically feasible, functional under certain circumstances. But as the tests proceeded, and the American machine continued to operate with unexpected efficiency, the engineer's words began to reveal something deeper: discomfort. It was no longer just a mechanical analysis. It was an internal breach of trust. One of the documents, classified as internal, dated October 1943, included the following sentence: "The vehicle exhibits operational characteristics that, while rudimentary, reveal surprisingly effective engineering." This line, dry, hid an admission. The Germans did not understand why the tank worked so well. It was as if they expected failures that never came. The expectation of technical superiority had been taught, repeated, and reinforced for years. But now, faced with a foreign tank that contradicted all the theoretical premises of the German project, the internal logic began to crumble. The engineers, trained in elite academies, experts in precision machining, now dealt with a vehicle made to run on a margin, and working better than their most meticulous creations. The questions began. In private sessions, technical comparative analysis groups initiated previously unthinkable debates. Why is an aviation radial engine adapted for ground use more reliable than the armor-specific Maybach engines? Why do helical gears, considered unsuitable for heavy tanks in our manuals, show less wear after 1,500 kilometers? We are designing for war, or to engineering. The minutes of these internal meetings, recorded in files at the Heereswaffenamt, the Army Weapons Office, reveal a pattern. The engineers went from distant critics to curious observers, and eventually to embarrassed admirers. An engineer notes almost with irritation, "The M4A1 is not just a simple machine. It is an intelligent machine. Its designers understood what we have forgotten. War is logistics, not aesthetics." The psychological impact deepened. For years, German engineering nurtured the belief that it was the guardian of technical perfection. The Panther, the Tiger, the Zeiss optical systems, the supercharged engines from Daimler-Benz. All of this was the pinnacle of European industrial capacity. And now a tank produced with a civilian philosophy by American assembly line workers surpassed their designs in durability, mobility, and adaptability. More than one engineer mentioned, in internal reports, that the real breaking point was philosophical. Germany designed tanks for engineers. The Americans designed tanks for soldiers. This simple inversion of priority explained almost everything. The Sherman accepted maintenance by any recruit with basic training. It could run on any type of fuel with little loss of performance. Their parts came in boxes marked with simple codes. The Panther, by comparison, required advanced workshops, specific tools, and skilled labor, a structure that disappeared on the front lines as Allied bombing raids closed factories and compromised railroad lines. The technical collapse evolved into a moral collapse. Many engineers began to lose faith in the superiority they swore to uphold. A November 1943 technical note filed under seal noted that the maintenance capabilities of the M4A1 are superior to those of any vehicle produced under current Reich industrial standards. This sentence, although wrapped in neutral language, was a sentence. Germany's technical elite was finally admitting that it had been outclassed, and not for greater genius, but for strategic humility. The Americans did not try to reinvent war. They tried to beat it with scale, standardization, and logic. A senior engineer at Henschel, after reviewing Hillerslieben's reports, made a handwritten note at the bottom of a memo. "We make monuments, they make tools, and tools win wars." This realization silently eroded the conviction of the experts. Many went on to advocate complete revisions to the concept of German armor. They asked for the replacement of complex parts with standardized versions. They suggested expanding the manufacturing tolerance to speed up production, but it was too late. The industrial structure of the Reich had been shaped for excellence, not volume, and any attempt to change that would take years, time that Germany no longer had. At the same time, American tank production was peaking. In December 1943 alone, the Chrysler, Ford, and Pressed steel plants delivered more than 2,300 Shermans. This equated, in a single month, to the total number of Panthers produced in the entire previous year. The difference was no longer technical, it was existential. Some engineers sought comfort in the idea that the Sherman's superior performance was circumstantial. Others, less idealistic, began to study American maintenance manuals as if they were sacred texts. The impact was so profound that in January 1944, a secret technical conference was held to discuss the learning points drawn from American engineering. For the first time, it was officially recognized that the American model is based on industrial values that should be considered in future project proposals. It was the beginning of a late, timid transition, and with no real chance of implementation, because it was no longer a matter of copying parts or adapting processes. It was a matter of recognizing that the enemy had won where Germany had not even begun to fight, in the philosophy of production. The psychological breakdown reached its peak with a sentence recorded in a final report from Kummersdorf, dated February 1944. She said, "M4A1 is the expression of an industrial thought that prioritizes the collective over the genius. It is, therefore, more dangerous than any single technical advance." The machine they had laughed at first now became a symbol of what they could no longer stop. In the next part, we'll look at how this perception spread beyond the engineers and began to creep in doubts even among Wehrmacht field officers, who saw Shermans emerging in increasing numbers and not breaking. During the first months of 1944, Kummersdorf's reports began to circulate between civilian and military departments of the Reich. The content was technical, detailed, and objective, but the reaction it generated was anything but rational. For the German armored doctrine, shaped by years of cult of technical superiority and the mythical figure of the supertank, accepting that American simplicity worked best was almost heresy. The concept of a vehicle designed to be good enough and delivered in the tens of thousands clashed head-on with the Nazi ideal of elitist excellence. The High Command did not know what to do with that information. Here's Waffenamt officials tried to soften the conclusions by rewriting the technical opinions with more neutral language. A meeting held in Berlin, with representatives of Henschel, MAN, and the Ministry of Armaments itself, had as its agenda the doctrinal consolidation in the face of the performance challenges observed. Translation: deciding whether the Sherman test data would be taken seriously or ignored. They opted for the second option. The decision had little technical and much ideological. Nazi Germany had built its war project on the pillar of technological supremacy. The Panzerkampfwagen 5 Panther was an icon of this design. Aggressive, complex, aesthetically imposing. The Tiger was a symbol of absolute strength, even if operationally unfeasible. To admit that an American tank with an adapted engine, civilian gearbox, and simplified maintenance surpassed these models in functionality was to admit the failure of an entire doctrine. The Reich did not design tools, it projected myths, and myths do not accept practical competition. An internal memo from the Armored Doctrine section recorded, "Field observations on enemy vehicles do not alter current doctrinal guidelines." This, in political terms, meant, we know that their tank works better, but we are not going to change. At the same time, the engineers who had written the Kummersdorf reports began to be moved to other areas. Some were sent to rocket sectors, others for defensive weapons development. There was clearly an effort to silence technical discomfort. An armored major reported in a personal letter that the Sherman question has become an inconvenient subject in the corridors of Berlin. The armored doctrine insisted on maintaining its pillars: superior armor, maximum firepower, technical complexity, and limited production. It was a recipe for defeat, but it seemed non-negotiable for an ideological leadership that saw technique as an extension of race. Meanwhile, the Red Army received thousands of Shermans through the Lend-Lease program. They praised its reliability, its ability to maneuver in extreme climates, its ease of maintenance with improvised Soviet parts. On the Western Front, the Allies were preparing for the invasion of Normandy. In American factories, every 30 minutes a new tank rolled off the production line. The logic of good enough was about to crush elitist perfection with sheer repetition. But in Germany, the military technical system could not yet accept the obvious. The tanks that worked were ignored. Tanks that broke were glorified. Nazi ideology did not accept the idea of an efficient tool. For them, each piece of war should be a reflection of the superiority of the Germanic spirit, even if it came at the cost of its functionality on the field. So Sherman's data didn't cause a makeover. They caused denial. The Reich chose to continue investing in increasingly complex projects such as the Maus, a supertank of more than 180 tons that never made it to the battlefield. Meanwhile, the M4A1, weighing just over 30 tons, crossed continents, climbed hills, faced ambushes, and, most importantly, was back in service the next day. This difference between engineering as a symbol and engineering as a tool became the abyss that would define the fate of war. Germany projected to impress, the United States projected to win, and this philosophical choice, invisible in the manuals, determined everything. A broken tank with superior armament is worth less than a functional tank with average armament. But for the regime that saw war as a stage of racial and technical greatness, this conclusion was unacceptable. As one German general said after visiting Kummersdorf, "We would rather fail with glory than win with simplicity." And they failed. In the next part, we'll look at how this gulf between symbol and function began to affect the battlefield. Because the reports ignored in Berlin would take shape in the diaries of soldiers who faced Shermans in increasing numbers, and that, even when hit, they advanced again. During the campaign in Italy and around Kursk, reality began to erode the technical illusions of the Wehrmacht with the brutal force of repetition. Operational reports from the Eastern Front showed an alarming statistic. In some panzer units, only 2 out of 10 Panther tanks were operational at the start of the offensives. The rest were awaiting maintenance, replacement of parts, or had been abandoned in the field due to transmission failures, overheating, or breakdown of the final units. In contrast, the Shermans, even in mountainous environments, heavy clay, or under constant bombardment, maintained readiness rates above 80%. The most disconcerting fact wasn't just that American tanks worked. It was that the Germans themselves began using them. Records of the 6th Army document at least 12 Shermans captured in Italy that were integrated into German units with makeshift paint and absolutely no structural modifications. A field report rated the performance of one of these vehicles as above average for continuous operations. The term used was verlässlich, reliable, a rare adjective in German documents on foreign material. Letters from soldiers at the front, partially censored, reveal an increasingly common feeling: frustration with the technology itself. An armored platoon commander reported that, after 3 days without spare parts for the Panthers, he considered abandoning the vehicles and requisitioning American captured as an alternative. Another from the casino sector wrote, "Better to be inside a moving tank than to die next to a parked masterpiece." The sentence was a sentence. The symbol of German technical greatness was beginning to be seen by the combatants themselves as a burden, something beautiful, but useless. The reports piled up and the truth was consolidated. The battlefield numbers confirmed everything Kummersdorf's engineers had anticipated. The Sherman didn't have to be the best tank. It just needed to be there, working, when the other failed. By January 1944, the Allies had produced more than 30,000 Shermans. Germany, until then, barely exceeded 5,000 units, adding Panthers and Tigers. For every Panther in the field, there were 6 Allied tanks, 4 of them Shermans. And more than the numerical disadvantage, there was the psychological one. While the Panthers broke before the fight, the Shermans arrived, fought, and could still be repaired the next day. If this surprises you, write in the comments, "Shocking data." Because war, like reality, has no patience with vanity. An intercepted letter from an officer of Army Group Center recorded the bitter realization: "They beat us not by steel, but by the chronometer." The phrase summed up the drama of the Third Reich. Its engineering was stuck in the past, while the Allies operated like a living production line. Reports of failures became so recurrent that the High Command itself ordered the standardization of preemptive retreats based on the expectation of mechanical collapse of the Panthers. In practical terms, this meant that German tanks were considered less reliable than the Allied generals' own projections. Technical supremacy had become operational superstition. The impact on morale was profound. Officers trained to rely on German military superiority began to doubt the tools themselves. The field instructions now included specific sections on precautions when operating Panther tanks in wet terrain, something unthinkable for a vehicle that should dominate any environment. Captured Shermans, dubbed obedient Americans by some German crews, were held as valuable reserves. They were less powerful, less armored, but they returned from the mission. The field had become the final court, and in it, the verdict was unappealable. Reliability trumps reputation. The engineers warned, the soldiers confirmed, but the generals refused to listen. Ideology had won over reason, for the time being, because in the next chapter, we will see how this logic began to turn among the Allies as well, how reliance on the Sherman, once seen as a logistical burden, became the linchpin of a strategy that would change the war, a strategy born not of genius, but of repetition. If the battlefield is the face of war, logistics is its heart. And in the heart of the Reich, in 1944, the pulse was already irregular. The industrial structure of Nazi Germany, contrary to the image of precision disseminated by propaganda, operated in functional chaos. The production of tanks, such as the Panther and Tiger, involved dozens of suppliers spread across different regions, many of whom worked with non-standard parts. Each manufacturer used its own specifications, unique tolerances, and distinct processes. The result was a system where a bolt produced in Nuremberg did not fit into the same housing manufactured in Dresden. Interchangeability, a vital concept in any long-term war, was virtually non-existent. Field workshops depended on specific technical maps for each production series. A Tiger from September 1943 required different parts than a Tiger from December of the same year. The same tank, the same designation, but a mutant, internal anatomy. This maze of versions and variations made it impossible to intelligently accumulate supplies. Each front needed a unique arsenal of parts, and each failure required an expert trained in the exact model. In contrast, on the other side of the Atlantic, the United States had turned its civilian automotive fleet into a war network. Chrysler's Detroit plant, originally designed to produce mass-produced automobiles, had been reconfigured in record time to make armored vehicles. The Sherman assembly line followed the same principle as a Plymouth: standardized parts, simplified operations, and volume as the central objective. The tank wasn't just a weapon, it was an industrial product. Each bolt had a unique specification, each module a standardized installation. The same gearbox was suitable for different models. The same electrical system could be reused. A recruit trained to operate the M4A1 could, within a few days, perform maintenance on the M4A3 or M4A2. The technicians learned by repetition, not improvisation. The manuals were simple. The toolkits came with everything you needed, and they worked. More than that, the Sherman was designed with a revolutionary principle for the time: field maintenance without an engineer. This meant that the tank did not require specialists to change critical parts. The radial motor could be removed by light crane and replaced in less than 6 hours. Suspension bogies came in blocks and could be swapped out like cartridges. The wrinkles were assembled in segments. Everything was designed for the exchange, not for the detailed repair. It was the difference between a war hospital and an artisanal workshop. The Panther required an arsenal of specific tools and technicians with years of training. The Sherman required 3 men with basic instruction, a manual, and a set of keys. In 1944, this difference translated into speed. The U.S. Army was able to recover an entire platoon of damaged armor in less than 48 hours. The Wehrmacht, in contrast, took up to 2 weeks to return half of its operational tanks to combat, and not for lack of bravery or competence, but for lack of parts. Because where Sherman needed a standard module, Panther needed a bespoke solution. This technical rigidity, coupled with the systematic bombing of German rail routes, created a fatal logistical bottleneck. Parts were not enough. Technicians couldn't handle it. Workshops retreated. Tanks gathered dust. At the height of the Normandy campaign, the Germans faced a cruel paradox. Their tanks were feared, but they were not present. On several occasions, Allied units encountered defensive lines without armor, not for lack of orders, but because the vehicles were stopped, broken, waiting for a type of part that only existed 500 kilometers away. Meanwhile, the Shermans were advancing. Each day, dozens were disembarked on the beaches. Each week, hundreds of new tanks crossed France. Each month, numerical superiority was consolidated, and not only in quantity, but in continuity. The American tank, because it was standardized, was part of a larger system, an ecosystem where each part served the whole. The Panther was a unique piece. The Sherman was a functional set. And if this seems like a technical advantage, the figures confirm the German disaster. By the end of 1944, more than 40% of the Reich's tanks were out of operation for lack of parts or repair capacity. In contrast, the Allies maintained availability rates above 75%, a difference that is not born in battle, but in the shed, on the production line, in the warehouse. If this impresses you, write in the comments. Logistics wins, because it is on the tracks of industry that the war really walks. But there was more. The U.S. Army itself had anticipated this supply war. Since 1942, it had invested billions in global stockpiles, shipping parts before the tanks even reached their destination. It was as if M4A1 already had its own pharmacy waiting for it on the other side of the ocean. There were tanks disassembled into boxes, ready for reassembly. Trains with parts crossed England without stopping. Mobile workshops operated in the field with complete autonomy. It was war as a continuous logistical operation, and in this scenario, Germany had no chance. The Sherman is no longer a tank. It became the symbol of a country that worked, the final cog in an industrial chain capable of transforming steel into mobility, oil into advancement, parts in presence. Every tank that rolled out of the factory wasn't just a machine. It was living proof that America had understood war as a problem of scale rather than genius. The Germans, stuck with the idea that a warrior needs a perfect sword, now faced an army armed with millions of sharp knives. In the next part, we will see the final price of this technical arrogance, because the same system that created Sherman was the one that allowed him to return day after day to the field. And the Panthers, as powerful as they were, had a predictable destination, the side of the road with smoke in the engine, and a simple, but functional, enemy approaching. In the last weeks of 1944, when German lines were retreating on all fronts and Allied bombing raids had already choked the industrial centers of the Reich, a group of engineers and officers met in Berlin to try to understand the technical collapse that was eroding the German armored force. The result of this meeting was a now historic document, the Panzer Commission Report, dated January 23, 1945. The tone of the text was no longer one of technical euphoria or racial superiority. It was a bitter balance sheet and a veiled admission of failure. The document began with a direct sentence: "The failures in the final units of the Panthers have reached a critical point. The troops' confidence in the vehicles is severely compromised. The phrase "dry and objective" sounded like a moral capitulation. The report analyzed dozens of occurrences of mechanical failures even before the fight. In several situations, entire units of Panthers were forced to abandon strategic positions due to simple inability to move. Transmissions collapsed after 300 kilometers of operation. The final gears, designed for higher theoretical loads, did not withstand the reality of the field. A specific observation highlighted that the excess torque generated in the curves destroyed the differential assembly with a frequency that was statistically unacceptable. In clear translation, the tank broke simply when trying to turn. The most serious, however, came next. An engineer from MAN, the maker of the Panther, wrote, "Our models prioritized performance and innovation over reliability and maintenance. Today we understand that this choice was wrong." It was the first time that someone in the German technical high echelon had admitted in writing that the design principles were wrong. The confrontation was no longer technical. It was moral. Germany recognized that it had built machines to impress, not to resist, that his obsession with excellence had ignored the reality of war. The Shermans, cited in the same report as technically inferior but consistently operational, were the mirror of the opposite choice. A Henschel engineer responsible for the Tiger wrote in a marginal note, "The Americans accepted limits. We don't. And that's why they win." The phrase was never published in official reports, but circulated among engineers as a bitter synthesis of everything that had gone wrong. War, after all, did not reward the technical ideal. It rewarded what worked. The Panzer Commission document also contained statistics that made clear the magnitude of the error. On average, 35% of the Panthers produced between July and December 1944 did not even reach the battlefield. They were lost in tests, transport, or failures before combat. The comparison with the Shermans was devastating. More than 90% of the American tanks delivered to the front operated successfully within the first 72 hours of the mission. In a war of attrition, this difference was lethal. The report tried to suggest corrective measures: simplification of projects, standardization of parts, greater training and maintenance. But it was too late. The German industrial system was already fractured. The factories operated at 40% capacity. The railroads were destroyed, and the resources scarce. The technical confession was real but impotent. On the front line, the consequence was visible. Armored troops reported the impossibility of planning missions with confidence. Commanders were hesitant to launch attacks because they knew their vehicles might crash on the way. The Reich armored doctrine, once a symbol of innovation, had become a source of insecurity. The technical elite, who once projected for glory, now wrote reports full of regret. A final excerpt from the Panzer Commission report read, "Modern warfare requires quantity, simplicity, and spare capacity. German industry so far has not been able to deliver any of these qualities." It was the death knell of a philosophy. More than that, it was the moment of the narrative turn. Technical arrogance has crumbled in the face of empirical reality. The industrial ideology based on genius and exclusivity had been defeated by an opposite philosophy, that of standardized reliability. The United States has not built better tanks. They built possible tanks, repeatable, functional, and that's why they won. The Reich, drowned in its own myth of superiority, failed to understand that war is won with constancy, not with spectacles. American engineering, by prioritizing what was sufficient to operate, outperformed what was brilliant but useless. A handwritten excerpt, added to the end of the report by a Daimler-Benz engineer, perhaps best sums up the quiet feeling that gripped the German technical class. "We were trained to create perfection, but we forget that perfection without presence is only vanity." It was the ultimate acknowledgement that they had lost not only the war, but the logic that sustained them. They lost because they believed that the war was a showcase when in fact it was a mudfield, where what matters is not to shine, but to come back the next day. In the next part, we will see how this technical recognition was reflected in the desperate actions of the German leadership, how, in the face of admitted failure, the Reich resorted to absurd designs, supertanks, and promises of miraculous weapons, in the hope that one last technical gesture would restore faith in the impossible. By early 1945, the Reich's industrial landscape was no longer made of steel, smoke, and efficiency, but of craters, black smoke, and smoldering wreckage. The collapse of German industry was not only technical, it was material, physical, hit at its foundation by a coordinated offensive that was not only aimed at defeating tanks in the field, but preventing them from even existing. The Maybach factories responsible for the Panthers engines were hit by serial bombing. Entire assembly lines were rendered unusable. Production fell 60% in less than 2 months. ZF Friedrichshafen, which supplied transmissions and final gears, also suffered catastrophic losses. In January, it produced half of what was needed to maintain the minimum replacement flow. More than destruction, what was seen was the disintegration of a productive ecosystem that had never been prepared for continuity under pressure. But the physical destruction was only part of the fall. The corrosion came from within. Pressured by unrealistic deadlines, the industry began to assemble tanks with defective parts, inaccurate fittings, and half-tested engines. Internal inspection reports document that, as of late 1944, at least 1 in 4 Panthers left the factory with some critical assembly failure. A new tank was already born doomed. Even worse, the workers were no longer the same. The German workforce had been decimated by years of military conscription. What was left on the assembly lines were old, young, and largely forced laborers. Thousands of prisoners of war, enslaved laborers, and citizens of the occupied nations were incorporated into the industrial effort, not with training, but with fetters. And in the midst of this environment of repression, sabotage emerged. Small, subtle, but constant. SS reports highlight an exponential increase in the frequency of deliberate failures. Loosened screws, parts with changed marks, tampered tools. It was not necessary to sabotage an entire tank. It was enough to compromise the cooling system, the lubrication of the differential, or the timing of the transmission. An invisible mistake, which exploded 200 kilometers away on the battlefield. The effect was devastating, because the trust, already shaken, dissolved with each inexplicable failure. Commanders no longer trusted the vehicles. The workers did not trust the supervisors. And engineers, once steel masters, now wrote crisis reports for fear of reprisals. Meanwhile, on the other side of the Atlantic, the scenario was different. The United States operated at full capacity. No American tank or critical parts factories were bombed during the entire war. The production lines worked in 3 shifts. The workforce was voluntary, trained, and motivated by propaganda campaigns that turned workers into invisible soldiers. The logistics chain was stable, efficient, and growing. The trains carried steel from Pittsburgh to Detroit. Continental engines arrived ready to be fitted. Each tank was assembled like a car, with efficiency, standardization, and quality control. Reliability was not a goal. It was a consequence of the system. By February 1945, as Germany struggled to deliver 120 Panthers a month, the United States was producing more than 1,200 Shermans. For every factory destroyed in the Reich, 10 new facilities were erected in the United States. For each batch sabotaged in Germany, an American convoy delivered parts that were tested, packaged, and ready for use. Industrial warfare had become a logistical massacre, and there was no way to hide it anymore. The German engineers, desperate, tried emergency solutions. They redesigned parts to simplify processes. They proposed lighter, less ambitious tanks, but they were ignored. The Nazi leadership still believed in superweapons. It required more Tigers, more 88mm guns, more fancy projects like the Maus and the E-100, steel monsters that would never see the field. As the actual tanks deteriorated, Hitler drew ghosts on paper. It was the ultimate refusal to accept that the war had been lost not by courage, but by the factory, for her absence. The irony of this story is that the solution was before them. The answer has never been more power, more armor, or more ingenuity. It was from the beginning reliability, durability, and scale. If you're enjoying unraveling these facts, show your support, like and subscribe so we can bring you more in-depth content. Because history, when told with data, reveals truths that survive time. The final collapse was not in Berlin. It was in every factory burned, every crane stopped, every technician killed, every part that never arrived. The Panther died before the fight. The Sherman lived beyond him. Because behind every American tank was a nation on the move. Behind the German tank there was an empire crumbling on the myths themselves. And if we have seen how the technique has failed so far, in the next part we will delve into what came after. How the Americans themselves, by getting their hands on German documents and interrogating captured engineers, discovered what the Reich never wanted to admit in public: a technical confession, written by those who resisted it the most. In January 1945, amid the chaos of the Allied advance, a disconcerting scene caught the attention of military observers on the outskirts of Bastogne. Sherman tanks, supposedly American, were advancing toward German positions. But it wasn't a tactical deception. It was a real operation by the 150th Panzer Brigade, an elite unit formed by Otto Skorzeny tasked with infiltrating enemy lines using captured uniforms, vehicles, and equipment. Among the most valuable items, Sherman tanks. And not by chance. Skorzeny had specifically requested the American vehicles because he was more confident in their ability to maintain operation on long missions than in the available Panthers. The operation failed, but the fact remained: German officers preferred to use enemy tanks rather than rely on their own. This was not an isolated case. During the fighting in Normandy and later in the Ardennes, units such as the 10th SS Panzer Division Incorporated captured Shermans into their inventory, especially for secondary missions, troop transport, or mobile fire support. In several Wehrmacht records, American tanks were described as useful, practical, and most significantly, more reliable than our own models in certain conditions. In an operational report dated 18th of September 1944, an officer of the division wrote, "Captured tanks of the M4 type are particularly valuable for rapid deployments. Its fuel consumption is predictable, and field maintenance is simplified." The irony was brutal. What had been derided as an assembly line product for illiterate soldiers was now valued by those who needed results, not prestige. In a letter from a field commander to the High Command, found among the post-war archives, the most emblematic phrase is perhaps this: "Give me 2 working Shermans, and I will replace a battalion of stationary Panthers." The ultimate symbol of German engineering had become a burden, the American tank, a lifeline. The reports follow. Officers of the 116th Panzer Division noted that crews preferred, whenever possible, to occupy captured tanks for patrol duties. And this was not just for camouflage or surprise, but because they felt greater confidence that the vehicle would take them back alive. The Sherman, even though it was a foreign tank, offered something rare at that stage of the war: predictability. Visual evidence confirms these reports. Photographs taken by U.S. troops in retaken areas show Shermans painted with Germanic crosses, hastily adapted with German radios, and even with operating maps pinned to the dashboard in German. In some cases, tanks were integrated into entire platoons, operating side by side with Axis armor. This required not only technical acceptance, but doctrinal adaptation. One of the most prominent points in the SS reports was the ease of training of the crews. Within hours, soldiers could operate the vehicle, something unthinkable with Panthers or Tigers, which required weeks of intensive learning. From a symbolic point of view, nothing could be more devastating to Nazi doctrine. The foreign tank, built by a nation seen as decadent, was now the bastion of German mobility. The very term "captured" has lost its meaning. What you saw on the fields of Europe were tanks that had switched sides, not out of political choice, but out of simple functionality. The Sherman proved to be the tank that even the enemy respected, and he did. What's more, records show that when Sherman tanks were damaged in combat, German crews scrambled to recover them. Officers of the Grossdeutschland Division mentioned risky night operations only to tow American tanks. In contrast, Panthers and Tigers with mechanical failures were often abandoned. In logistical terms, the explanation was simple: the Sherman could be repaired in the field. Their systems were affordable, its parts easy to adapt, and even with scarce supplies, mechanics were able to improvise solutions. It was the pinnacle of empirical proof. The tank that survives on the field is the one that serves, not the one that impresses in the parades. And the irony does not stop there. In 1945, upon being captured by the Allies, Waffenamt engineers were interrogated about the use of Shermans. On several occasions, they admitted that the vehicle had been incorporated not as an emergency resource, but as part of the operational doctrine. One even said, "The Sherman was the only tank we could rely on for certain maneuvers, because we knew it would turn on, walk, and shoot." This confession, made without coercion and recorded in the OSS archives, today represents the final collapse point of the narrative of German superiority. When the enemy himself trusts more in what he should ridicule The war of ideas is already lost. And here is one last visual observation. One of the most symbolic records found after the war shows a captured Sherman, still with marks of use by the 10th SS, abandoned on a road, your engine broken. Next to it, a Panther, imposing, but also inert. 2 tanks killed, but only one of them, according to the Allied recovery report, had completed more than 1,800 kilometers before failing. The other, according to American technicians, showed wear on parts that indicated use of less than 300 kilometers. The American tank lost, but it went all the way. The German never had a chance. In the next part, we'll dive into the post-war era, when the German engineers themselves, now working with the Allies, revealed in interviews, reports, and memoirs what they really thought of the Sherman and what they learned from their brutal simplicity. Because the war is over, but the lessons of reliability were just beginning. In 1956, the newly formed Bundeswehr, the new West German Army, began studies to develop its first main combat tank since the fall of the Third Reich. The task was both technical and symbolic. Germany, now divided, needed an armored vehicle that would represent not only its military defense but also a definitive break with the mistakes of the past. At that time, veteran engineers, many of whom had served in the former Waffenamt or worked in the Nazi arms industry, were drafted for this new project. And contrary to what many would expect, they didn't look at Panther. They didn't look at Tiger. They looked at Sherman. The technical and doctrinal reports of the first years of the Bundeswehr are unambiguous. The American tank that so humiliated German engineering had left deep scars. Documents from the Federal Institute of Military Technology reveal that the Sherman's mechanical reliability, modular design, and the industrial rationale behind its mass production became the indirect model for what would eventually become the Leopard 1. The new design would not be a walking fortress like the Tiger, nor a sensitive maintenance machine like the Panther. The Leopard would be fast, light, easy to maintain, and above all, reliable. For the first time, Germany would choose to design a tank based on logistical reality, not doctrinal ambitions or ideological symbols. This technical leap required historical humility. Engineers who had signed superiority reports in the 1940s now wrote reviews praising the M4 Sherman's design philosophy. One of them, Ernst Kniepkamp, a designer involved in the development of suspensions during the war, stated in a 1958 conference, "We have learned that simplicity is not synonymous with inferiority. The real technical challenge is to create machines that survive human error, not rely on constant excellence." That phrase, uttered by a veteran of German war engineering, echoed exactly what the Sherman had proved, and what Germany had ignored out of pride. In practice, the Leopard 1 reflected this new technical maturity. Its design prioritized interchangeability of parts, easy access to all mechanical systems, and integration with standardized Western logistics chains. Its engines were tested for durability above 5,000 kilometers without the need for major revisions, an unthinkable goal during the days of the Panther. Drivetrains, rather than pursuing extreme innovation, were based on robust and tested models. The turret was wide, the hull designed to receive upgrades. Modularity, Sherman's trademark, was now at the heart of German armored doctrine. More important than the technical details was the philosophy that guided these choices. The Leopard 1 was born out of a rebuilt Germany, where the engineer's prestige was no longer in extreme refinement, but in functional robustness. The tank didn't need to win parades. It needed to survive real combat, in real settings, with real operators. This mentality, inherited directly from the lessons of 1945, was decisive for the new armored vehicle to become a reference in NATO in the following decades. But there is an even more revealing fact. In a comparative field analysis conducted in 1967 by the Bundeswehr itself, it was recorded that the average operational readiness rate of the Leopard 1 was over 85%, even in adverse weather conditions. In contrast, the Panthers of the war rarely exceeded 30% under similar conditions. Germany had finally overcome its obsession with mechanical perfection and understood that war is won with what works, not what impresses. This paradigm shift has also influenced other European countries. French, Italian, and British designers began to study the post-war German model as a reference for adapting to the new theater of operations of the Cold War. The Leopard 1's influence spanned decades, but its seed, silent and ironic, had been planted by the same tanks the Reich despised. The Sherman, far from being an obsolete icon, has become ground zero of a modern technical philosophy, not for what it was, but for what it forced others to become. In interviews in the 1970s, several engineers who participated in the Leopard program cautiously admitted their intellectual debt to the American tank. One summed up the collective feeling with disconcerting accuracy. When we stopped trying to prove that we were the best, we started building what really needed to be done. This is perhaps the greatest irony of the entire narrative. The most underrated tank of World War II became, years later, the backbone of the armored doctrine that Germany itself would export to the world. In the next part, we will see how the United States consolidated this logic in its own post-war period, how the doctrine of reliability, modularity, and mass production not only won the war, it shaped peace. Because the Sherman wasn't just a temporary victory, it was the beginning of an era. The Sherman tank, made of steel and radial engine, carries more than a tactical function. Carry an idea. In its functional simplicity, in its design designed for human error, in its structure made not to impress but to last, it reveals a mindset. While the Nazi Reich designed tanks as mechanical masterpieces, which required operators trained as concert performers, the United States built machines for soldiers, for ordinary men. This difference, almost invisible in the technical diagrams, became glaring on the battlefield, and it says more about the societies that produced them than about the machines themselves. In Germany, engineering was an expression of power and prestige. Each Panther reflected a philosophy where the engineer dominated the worker, and the final product should be worthy of technical admiration, even if it came at the cost of functionality. The idea of trustworthiness seemed too simplistic, almost vulgar, to be an end goal. In the United States, engineering was seen as a tool, not an end. The American tank didn't have to be the best. It needed to be there. I needed to call, walk, shoot, come back, and repeat. This is the soul of American logistical superiority, the victory of the mentality that accepts the imperfect as long as it works, over the perfect that fails at the crucial moment. And the most disturbing thing about this comparison is what it reveals about values. The Panther was an elitist tank. It depended on exceptional operators, specialized maintenance, hard-to-obtain parts, and complex transportation. It was a system that did not forgive error, and therefore failed. Sherman was the opposite. He forgave inexperience, resisted improvisation, adapted to chaos. In other words, he trusted the common man. This is not just a technical choice. It is a moral choice. A society that projects towards human fallibility is a society that understands war as a human phenomenon, not as a stage for genius. This philosophical difference is manifested in each screw. In Germany, tank production lines were slow, decentralized, vulnerable to bombing, and full of variants. Each Panther was slightly different from the last. In the U.S., factories such as Ford and Chrysler have adapted car lines to produce tanks with speed, standardization, and gigantic inventories of interchangeable parts. It was the pure application of industrial thought to war, a thought that placed the collective above the artisanal, the functional above the aesthetic, the available above the ideal, and the results are undeniable. While Germany produced 6,000 Panthers with difficulty, the United States manufactured more than 49,000 Shermans. Not only did they win by quantity, they won because the tanks worked. What German engineers called inferior design was actually industrial maturity. It was understanding that tanks break, that wars are won by maintenance, that strategy without supply is fantasy, and that genius without logistics dies alone on the road without reverse. The impact of this transcends the technical field. The Sherman became the victory tank because it worked for men who weren't mythological heroes. They were citizens, improvisers, field mechanics, soldiers with no time for theory. And it is precisely because it was built with this spirit that it survived the war itself. After 1945, Shermans continued to operate for decades. They were used by countries on all continents. They fought wars that their designers never imagined, because they were made for this, to exist, to resist, to return. This is the real legacy of a machine, not the number of enemies destroyed, but the number of times it has fulfilled its function. The greatest irony of World War II is that Germany lost not only on the fields of France, Russia, or Africa. He lost on the drawing board. He lost in the workshop. It lost when it decided that tanks were showcases of technical supremacy, rather than tools of logistical supremacy. And this lesson, painful, humiliating, transformative, was forcibly learned by its engineers, its commanders, its mechanics, when they tested the captured Sherman and found no fatal flaws in it, but simple solutions. They had to admit, they didn't know what they didn't know. And this admission, more than any explosion or combat, is the moral center of this story, because it reminds us that wars are won, not only with strength, but with humility, that the true power lies in recognizing one's own limits and designing based on them, that technical arrogance can be as lethal as a tactical error, and that real superiority is silent. It doesn't need subtitles. In the next and final part, we will end this journey by revealing what this story represents today, how Sherman's legacy echoes in modern doctrines, and why, in the aftermath, the war he won was bigger than World War II. It was the war against the technical ego itself, and he won, with reliability. At the end of the long journey through this history, it is impossible to ignore the central fact that runs through every test, every report, every march recorded at Kummersdorf. Germany was not only defeated on the battlefield, it was defeated before in the very act of conceiving its war machine. When the captured Sherman crossed the gates of the test center, it was not just an enemy tank entering the heart of German engineering. It was a mirror. In it, engineers saw reflected the fragility of a doctrine built on theoretical perfection, technical elitism, and contempt for logistics. They saw that their Panthers and Tigers, icons of industrial pride, were unable to support their own weight. They saw that sophistication without robustness is only mechanical vanity. They saw that war does not forgive machines that require geniuses, but rewards those that resist at the hands of ordinary men. By the time the reports confirmed what the Tunisian desert had already whispered, the German defeat ceased to be military and became ideological. They were trying to win a modern war with a pre-industrial philosophy, and it is from here that the great universal lesson is born. History shows time and time again that logistics shapes strategy, that industry determines victory, and that reliability trumps brilliance. The Sherman was not the best tank of the war. It was the tank that was there. The tank that arrived on the battlefield while the rival broke down on the road. The tank that could be repaired by any trained hand, which accepted dust, mud, human error, improvisation. And this is the truth that crosses borders and eras. In any conflict, military, economic, or technological, the winner is the one who can do it more often, for longer, with more consistency. The winner is the one who builds systems that work, not monuments to genius. The winner is the one who understands that the collective sum surpasses the individual brilliance. Mechanized warfare has taught this with brutal clarity. Quantity is quality when it means availability. Simplicity is power when it means continuity. Reliability is strategy when it means survival. Germany itself in the post-war period admitted this fact. In 1946, a high-ranking officer of the former Wehrmacht wrote in testimony to the Allies, "We have not been defeated by better tanks. We were defeated by vehicles that always arrived." This sentence, dry, direct, sums up all the irony of this narrative. So, if you value this deep dive into historical truth, leave your like and subscribe to the channel. It is this support that keeps serious research and the reconstruction of facts alive. Comment which data shocked you the most on this journey. Was it the Sherman's 2,000-kilometer lifespan, the Panthers breaking before seeing combat, or the German reports praising the enemy tank? Also, activate the bell so you don't miss the next devastating chapter of military history. And now, before you go, remember, this story doesn't end here. Each war, each machine, each technical decision carries within it echoes of human choices. In the video that will appear on the screen, a new historical truth awaits you. Another hidden cog in the past. Another moment when industry, logistics, or engineering decided the fate of entire nations. Don't go away yet. Listen to the next real story that will appear on the screen. Always remember, logistics determines strategy. Watch the next video here on the channel with another incredible story.